We can now factor this guy, can't we? What does that factor into? One and one. And what are my signs? So can't I write this as x plus 1 quantity squared? Anytime you take something times itself, you can write it as squared. Okay? What's this one going to be? X squared minus 6x plus 9. X minus 3 quantity squared. Okay? And what's this one going to be when we have x squared plus 18x plus 81? Good. X plus 9 quantity squared. It's a binomial squared because these are called perfect square trinomials. Okay? They're going to make our life easier. All right, so here we go. We are to solve x squared plus 30x plus 225 equals 121 using square roots. So we're on the back of your sheet. We're going to do 2 examples together, and then you'll have 4 problems to work that are just like it. I don't. We had an extra student, and I have one back there. Okay? So we're going to do 2 problems together, then you'll have 4 problems, then we'll do 2 of another type of problem, and you'll have 4 problems to work, and then 2 more and 2 more. And that'll be your assignment for today. Okay? So here we go. So if we're going to solve this using square roots, what do you notice about the left side of your equation? Okay? That's the first thing we want to think about doing, right? Is to take the 121 to the other side. And I wanted to do the same thing. I wanted to bring everybody to one side. Right? But what I want you to do first before you use that instinct, and that instinct is accurate every other time, is to say, wait a minute. I have a trinomial here. Is it a perfect square trinomial? Okay? So that's the first question to ask. Is it a perfect square trinomial? Okay? I saw Dylan nod his head. Does everybody think that it's a perfect square trinomial? Okay? If it is, it can be written as something squared. X and x, right? And what's our square root of 225? 15. If I take 15 and 15x and 15x, will I get 30x? Yes. So this is a perfect square trinomial. This is why we did a lot of those special cases with the perfect squares that I wanted you to recognize, because we were going to see this now. So this is x plus what? Good. Quantity squared, isn't it? Is 121 a perfect square? Which one? 11 squared. Okay? So what does that mean? How can we solve that now? Perfect. We can square root both sides. They're both squared. When each side is squared, we can take the square root of both sides. Okay? Make sense? All right, so let's do that. So as we take the square root of both sides, we're going to get good old x plus 15, right? What are we going to get on the other side? Square root of 11 squared is 11, or negative 11. Thank you for not forgetting the negative 11. We have 2 answers here, positive 11 and negative 11. Okay? That means that we're going to get 2 answers when it's all said and done. Okay? The first answer, no, how do I get the x by itself? Perfect, minus 15 from both sides. So now I'm going to have 2 different things going on here. I have a negative 15 plus the 11, right? And I'll also have a negative 15 minus 11. So I get 2 answers. Now what's negative 15 plus 11? Negative 4. What's negative 15 minus 11? Negative 26. So we don't want to lose one of our answers by forgetting to put our plus or minus here. Most of the time they will have 2 answers, unless this happens to be a 0 over here, and then they only get 1 answer. Okay? You cool with that? All right. Next one, solve 4x squared minus 24x equals 36, or plus 36 equals negative 490. What's your first question you ask yourself? Is it a perfect square trinomial? So then write them as a binomial squared. What's the square root of 4x squared? 2x, good. Okay. What's the square root of 36? 6. Okay. So we're going to have a 2x and a 6. And what will the sign be? Minus. Okay. Everybody cool with that? Did a lot of work with those, so hopefully they're fresh and familiar and not something that's foreign. Okay? Yes, sir. So we got to think about this negative 490 next. Okay? Was it a perfect square like 121? No. So we're going to set this equal to this negative 490. And even though it's not something that's a perfect square, can we still take a square root of it? Yeah. Okay, so they won't always be perfect squares on the right-hand side, but in this particular section, they should always be perfect squares on the left-hand side, or we can make them that way. Okay, so far so good? All right, so let's take that square root of both sides. Left side's easy, right? The quantity 2x minus 6 squared under the square root becomes 2x minus 6. Okay. The right side looks a little scary. I see a negative, and I see a perfect square in there. What's the perfect square in there? 7 times 7 gets us 49, right? So this is 49 times 10. What comes out? The 7. What stays in? The 10. And what else has to come out? The I. And then what am I not supposed to forget? Plus or minus. it's messy. That's Algebra 2. Algebra 2 is messier. We don't get as nice of neat numbers. We get some messy things. That's okay. Okay? Almost there. What's the last step going to be? Oh, 2 steps. Get x by itself. So when we get the x by itself, it's got 2x hanging out with a negative 6. What's the first thing we do? Add 6. Excellent. So we'll have 2x equals 6 plus or minus that 7i square roots of 10. Okay. Now what? Divide by 2. And your answer will be a nice combobulation of stuff. We'll have a 6 plus or minus 7i square roots of 10 all over 2. And since they don't all have a 2 in common, we can't divide anything out. We leave it exactly like that. And that's how you'll see the answers on the ACT, on standardized tests, and so forth. Okay? You guys think you can do the next 4 by yourselves? Or do you need to see one more? Thumbs up if you think you can do the next 4 by yourself. Awesome. Okay. All right, so let's look at the next set. So we're going to find a value of c that makes each expression a perfect square trinomial, and then we'll write it as the square of the binomial. Okay? Just like our bell opener. Okay, our bell work. So number 7 shouldn't give you too much trouble. If you think about those algebra tiles and how we arranged them to make a perfect square. If we have an x squared block and we have 10 of the green x boxes, how many beige colored boxes are we going to need? Excellent. Very good, very, very good, very, very good. Awesome. All right, so how many beige colored boxes are we going to need? 25. I heard a couple people whisper. Say it out loud with pride. Why is that? Because we had 10 of them, right? We need to split them up evenly, 5 on one side, 5 on the other. And then when we take the 5 times the 5, we get 25. Okay? So the key to doing this is to take 1/2 of this middle term and square it. Okay? 1/2 of b squared. Now, where in the heck did I get b from? Yeah, this understood number in front here is my a. That was a 1. The b is always the number that's times the variable itself, not the squared variable. And the c is the constant. Standard form. Okay? And a lot of people just say that's 1/2 the middle term squared. Okay? However you want to remember it, 1/2 of b squared or 1/2 of the middle term squared. Make a note of it so you don't forget. Okay? Now we want to write that as a binomial squared. So what's it going to be? They took away our x's, didn't they? G plus 5 quantity squared. Another thing Algebra 2 likes to do, they take away our comfortable x and throw in different variables. Okay? But we can handle that. All right, 8's a bit more of a challenge, especially if you don't have a calculator. Got to bring your calculators. More and more of you bring in calculators every day. Yep. And you can leave it as a fraction. So what is half of 7? 7 halves. If I square 7 halves, guys, I'll have the mental math skills to do this. Yep, exactly. And negative 7 squared is? And let's leave it, don't give it as a decimal, just leave it, because most of the standardized tests are going to leave them as fractions. So 7 squared is 49. 2 squared is 4. So leave it as 49 fourths. Okay? So 49 fourths is our C. And what's our binomial squared going to look like? What do you think, Drake? Well, what did it look like here? We took our 10, took half of it and squared it. And there's the half of it, right? So if we took our 7 and took half of it and squared it to get this guy, what actually still goes here? 49 over 2, yep. Or I'm sorry, not 49 over 2, but 7 over 2. Okay? It ends up being just that half the middle term. Okay? All right, everybody good with these kinds of problems? You've got 4 of them on your own. Thumb up if you're okay, thumb down if you're not. I can show you another one. Okay, let's look at another one. Okay, so the next one on your sheet says that we are to take y squared minus 14y plus c and figure out what has to be added to it to make it a perfect square trinomial so we can write it as a binomial squared. Okay, so first step is always to take half of the middle term and square it, right? Half of the negative 14 and square it, okay? $49, everybody get 49. Okay? Now you've made it a perfect square trinomial. So what does it look like as a binomial squared? And what sign should be in the middle? And we need our little squared guy. Okay? Okay, so let's look at one more fraction one. I'm sure we've got another one. Which other one's going to be fraction? 10. Okay, let's do 10. We have x squared plus 13x plus c. Okay. So all you have to do is say half of the middle term is 13 halves. You can leave it as a fraction. When I square that, what am I going to get? Square the numerator, square the denominator. What's 13 squared? 169. What's 2 squared? 4. So it doesn't have to be anything tough. Half of it, just put it over 2. If it doesn't come out evenly, leave it over 2. Square the top, square the bottom. Okay? Now it's a perfect square trinomial. What is it? 13 over 2. 13 over 2, leave it as 13 over 2. And what's my sign? Plus. Okay? All right. Here we go. All that work was in preparation to do this. Solve by completing the square. Okay? So, we have a trinomial. And the first thing we always think of when we have a trinomial is, can we factor it? Okay? Factors of 5 that will add to get 18. Are we ever going to get there? No, it's way too small. Can't factor it. We also look and see, do we have a perfect square at the front and a perfect square at the back? Nope, so it's not a perfect square trinomial. So we need to make it a perfect square trinomial. Okay? So what we're going to do is move this 5 to the other side so we don't have to worry about it for a while. Okay? It was 5 on the left side. What will it be on the right side? Negative 5. So we'll have an x squared minus 18x. Leave a space and put negative 5. Now, how do I make the left side a perfect square trinomial? We just did it in the last step. Don't worry about the right side. Half of the middle term is 9. Squared is 81. Okay? Now, here's the thing. If I add 81 to the left side of my equation to make it a perfect square trinomial on the left, what do I have to do to balance the equation out? Dawson says add it to the other side. Does everybody agree? Anytime we do something to one side, we have to do it to the other to make it balanced, to make it the same. Okay? Now your left side is a perfect square trinomial. Add an x. What's it going to be? Negative 9. X minus 9.
Anyone made the connection that whatever this is?
Uh-huh. So it saves you some time if you write your half middle term. Okay. What's the right side going to be? 76. Okay, 76, positive 76. Now we're back to one of those problems that we solved earlier. Square root both sides, very good. So we square root both sides, so we've got a perfect square over here and just a single term over here. So we will have an x minus 9 on the left side, but 76 is even, so I suspect it might have a perfect square in it. 76 divided by 2 is 38, right? Divided by 2 is 38 divided by, or 76 divided by 4. 19. So this is 4 times 19. Remember all that work that we did to get those perfect squares out? Okay. So when we take the square root of 76, what are we going to get? Simplified. Good. Plus or minus. 4 comes out as a, what stays in? Okay. Just about there. Last step. Add 9. When we add 9 to both sides, we'll get 9 plus or minus 2 square roots of 19, and that's exactly how we want it to look. No decimals. You don't have to write them as 2 separate answers. It's just one nice, neat package, all wrapped up in a bow. Okay. Next one's going to have a fraction. Got an odd number in there, right? First step. We want to get a perfect square. We check to see, can we factor 8 factors of 8 that add to get negative 3? Nope. Okay. And not a perfect square, not a perfect square, right? So the very first step is going to be move that 8. Leave some space and find your C. That's half of your middle term. 3 over 2. 3 over 2 squared. 9 over 4. If I add 9 over 4 to the left side, what do I have to do to the right side, Vivian? Add it to the right side. Here's where it gets a little tougher. That's okay, we've got our calculators. Okay. Left side is now a perfect square trinomial. Let's write it as a binomial squared. Y minus what? 3 over 2. Quantity squared equals. Okay, be nice if 8 was over a 4, because then we could combine them. So how many fourths are there in 8? 32. We have to take the top and the bottom times 4 to get our fourths. So we'll have a negative 32 fourths plus a positive 9 fourths. And again, you can use your calculator to do this. You could use your calculator to say negative 8 minus, and use that fraction button, 9 fraction 4, and you'll get the same thing. But negative 32 plus 9 is how much? Negative 21. So we're going to have a negative 21 over 4. Number 23, 32 minus 9. Everybody get 23? Okay. Just about there. Now what? Square root both sides. So y minus 3 halves equals yep. So we can split it up. We can call this the square root of a negative 23 over the square root of 4. Okay, what does that negative in the radical do? Square root of negative 1 is I. It's coming out as an I. Can the 23 come out? Nope. But what can the square root of 4 become? 2. And what am I not supposed to forget? My plus or minus. Last step. So y will be not a positive or negative 3 over 2, and the other side it's a positive 3 over 2 plus or minus I square root of 23. If you want to write them both under their own little 2, that's okay. If you want to combine them all under the same 2, that's okay. This is equivalent to 3 halves plus or minus I square root of 23 over 2. Your choice. Just recognize that they're the same, so if you see them on a standardized test as an answer, you know that that's what they are. Okay? Just about out of time, but I'd like you to get out your foldable from yesterday. Because it took us a little longer yesterday to do our activity than I had planned, the syllabus or the blog is off a day. I'm going to adjust things. So this is going to be due today. Okay, then we'll do a book assignment tomorrow. Okay, so I'll adjust that on the calendar. And so you have examples and problems to work yourself. Examples, problems to work yourself. Okay, but let's talk about the completing the square method. How do we write down what we just did? What was the very first step if you're completing the square? Once you realize it's not something that we can factor, it's not something that we can take the square root of immediately, it's not a perfect square trinomial, what's the very first step that we do? We try to factor. Yep, can't factor. And it's not a perfect square, not perfect square. Okay, so now we realize we have to use completing the square method. Very first step is to always get the c to the other side. Okay, so step 1, move c to other side. So we'll have x squared plus 30x, leave some space, equals 104. What's the next step? Half the middle number squared. And if you want to write it as half the middle number squared or half of b, because you don't have a lot of space, either way, whatever works for you that you'll remember. Half the middle number squared. So half of 30, 15, 15 squared. 225. Okay. So now I have a perfect square trinomial on the left side, right? So you write your binomial squared. we'll have x plus 15 squared equals, and when we had a negative 104 plus 225, what are we going to get? 121. What's your next step? Square root of both sides. And when we take the square root of 121, what do we get? Careful. Plus or minus 11. Don't want to lose one of those answers. Okay? And then the last step? Yeah. Solve for x. Subtract 15 from both sides. So x will be negative 15 plus 11 and negative 15 minus 11. Negative 15 plus 11, negative 4. And negative 15 minus 11, negative 26.
You have it like this on the paper. What form is it? What form is it? Vertex form. What's the vertex of that parabola? Negative 15 and 121. And what are the x's? Where does it cross the x-axis? See this now? Put it all together.
Okay. All right. That is it for today. You have your assignment, and I'll update the blog to reflect the change.